Welcome to today's chemistry class with the master. Today we'll be discussing gas laws. And one of the gas laws today we'll be talking about is the Gay-Lussac's law of combining volumes. And the law states that when gases react, they do so in volumes which are in simple ratio to one another and to the volume of their product, if gaseous, provided that temperature and pressure. In this law, we don't consider temperature, we don't consider pressure, because these parameters are constant. Even if you are given a problem that contains these two parameters, we don't consider it. For example, if hydrogen gas reacts with oxygen gas, definitely we know we're going to form water in gaseous state. Remember, the law specifically told us that those reactants and product must be in gaseous state. Now we have like this: hydrogen gas H2 in gaseous form combines with oxygen gas to give us hydrogen water in gaseous state. Now this is the balanced equation of the reaction between hydrogen gas and oxygen gas. Then from the law, the volume of hydrogen gas that reacted or sparked with oxygen gas is 2:1. The volume of the product formed, that is the water, is 2, as you can see from the balanced equation. You must make sure that the equations are well balanced before you start whatever you are doing there. Then from there, you are going to be given a problem, and you'll be asked to find the volume of the unreacted gas or the excess gas, and also the volume of the residual gases or gas formed. That's the one of how we're going to start today's problem or topic. For example, what volume of oxygen will be left unreacted when a mixture of 100 cm³ of hydrogen and 200 cm³ of oxygen are exploded in an endiometer? So first of all, we're going to write the balanced equation for the reaction. As you can see on the board, hydrogen gas reacting with oxygen gas to give us water in gaseous state. Second stage, you balance the equation, because the law is talking about the ratios of the reactant and product. Here the equations were balanced first. If you look at it now, hydrogen is 2 at the right hand side, but it is also 2 here. Oxygen 2 at the left hand side, but it is 1 here at the right hand side. What do? You start balancing by using 2. You don't use a number 1, because number 1 remains the same. So you put 2 here as 2 molecules of water or 2 volumes of water, and 2 volumes of hydrogen gas. So this is a balanced equation. Then stage 3, write out the ratios of the balanced equation, which you're going to have as 2 hydrogen gas or 2 volumes of hydrogen gas to 1 volume of oxygen gas. So the product, as the law says, also give us 2 volumes of water. This is the volumes or reacting volumes in their ratios. Then the volumes of what they give you before the reaction. They give us that 200 or 100 cm³ of hydrogen gas. So volume before reaction now, or volume before reacting, is going to be 100 cm³ of hydrogen gas. Volume of oxygen before reaction is 200. You put it here, 200 cm³ of oxygen gas. There is no volume of water given to us, so you dash it or put 0 there, 0 cm³, because nothing was given to us. The next one is to, using the ratio you have on the board. Of course, you know that if hydrogen is 2, from the ratio I have here, 2:1. If hydrogen gas is 2, oxygen gas is 1. So if here is 100 cm³, what is the half of 100? Which is 50. I'm using the ratio as a case study here. That's why you must get a balanced equation properly before you start solving any problem here. So 100 is here. So I have 100 cm cube of hydrogen gas. Then the ratio of hydrogen, I repeat, to oxygen is 2 to 1. So if 100 is here should be what? 50. You have 50 cm cube. Remember that the ratio of hydrogen gas to water is 2:2. So what I want to have here, since 2 is here and 2 is here, therefore you have 100 here, you have 100 here. So you have 100 cm cube. Why am I doing that? Because hydrogen gas and water has the same volume, 100. So the next, think of what is the excess gas. The excess gas is the volume of the gas that do not completely react. That's why they use the word excess. So what the gas is now in excess, of course, from the ratio here, this is going to, you must continue to use the ratio, the balance ratio you have done, using the volumes here. So since here is 100, here is 50. Initially, we are giving 100 and 200. Instead of 50 here, they gave us 200. So what gas is now in excess? The gas that is now in excess is oxygen, because they would have used 50 cm cube from the ratio we have here, but they use 200 cm cube. So what is the volume of the gas that is now in excess? You subtract the given volume initially before the reaction you subtract the volume you got after reaction from the given volume before the reaction, which is 200 minus 50, which is you're going to have 150 cm cube. So the excess gas here is 150 cm cube. Now another one we are asked, I want to talk about here is that when you're asked to find the volume of the residual gas, of course we have actually studied the question. The answer here is 150 cm cube of oxygen, which is the volume of the excess gas left unreacted. Hope that is clear. The next one is to be asked further to find the volume of the residual gas. Please, residual gas here is talking about the volume of the product formed with or plus the volume of the excess gas. So you can go ahead. Imagine I'm asked to find the residual gas, the volume of the residual gas. And I say volume of residual gas is equal to volume. I'm not giving the formula, please. Volume of the excess gas, which we have gotten on the board as 150 cm cube, plus volume of the product. So by what I have here now, residual gas now, if I should use the RD here, or RG, residual gas should be 150 centimeter cube plus 100 centimeter cube, which is the volume of the product. The answer gives us 250 centimeter cube. That is the residual gas. Before I sign out for today, I would like you to have this assignment as the test of what I've taught you today. 120 centimeter cube of hydrogen we are sparked with 60 centimeter cube of oxygen at 110 degrees Celsius. What is the volume of steam produced? These are the reacting equations, and I have the options there: A 30 centimeter cube, B 60 centimeter cube, D 90 centimeter cube, and D 120 centimeter cube. Please, this is meant for your assignment. Try to do it and send your answer at the comment section. Ask questions while you are confused. So next time we meet, we're able to tackle it. I want you to like my video, subscribe, and share. Thank you very much. Till we meet next time.